Hello, my name is Brennan Remington, and this is the third episode of Pancake Psychology. Now, the topic that we're going to be talking about today is statistics, and I wanted to kind of talk about hypothesis testing too, just as like a good kind of entry into statistics to demonstrate some of the principles I'll talk about. And I tried to keep it really basic, with just really functional definitions that you need. It's the end of the semester. I just finished my last finals. I've got my Christmas sweater on. So anyway, statistics. Simply put, there's no field of psychology, there's no validity without statistical evidence to back it up. No survey, no treatment, no information in general is going to be meaningful without being statistically significant. Anything that isn't statistically significant is basically just a pseudoscience, just not backed up by any research claims. Now, a good definition that I found for statistics was by the APA, our beloved APA, and they defined it as being the branch of mathematics in which data is used descriptively or inferentially to support or find answers for scientific or other quantifiable questions. Now, there's a large difference between descriptive and inferential statistics, being that descriptive statistics aims to summarize the data that's being examined. So think of it like you have a data set and you're looking at the mean. If the mean of that data set is 17, that is a description of the data set. It doesn't apply to anything else necessarily. With inferential statistics, we focus on applying conclusions that we draw from the data set to a larger audience. So think of that as looking at, okay, the mean is 17. Now, in general, is the mean going to be similar whenever we interview other people? And that's where hypothesis testing is going to come in later. So in stats, definitions are very important. So there's a couple more essential ones to just kind of quick fire out of the way. So first, what's a statistic? Well, a statistic is a piece of data generated by observing a sample. What's a sample? A sample is a subset of a population. What's a population? A population is the entirety of what you're observing. And then data about a population is called a parameter. And then my stats professor always used to tell us, she used to drill in our heads, a parameter is the truth. You're always trying to find the parameter using a statistic. Think of statistics as having the goal of predicting these parameters through an observation of a smaller group, the sample. We wouldn't want to test everyone on Earth in order to find something out. So instead, we elect to create these groups in order to see if there are results that we can generate, that we can generalize to make the testing a lot easier. Now, definitions of populations are super important in the field of statistics, and that's another one of the things that was drilled in my head whenever we were learning stats. So an appropriate way to define a sample, just as an example, would be college students who are absent from Professor J's statistics class in fall of 2020. The reason it's so important to be so specific is because the results that we generate will be used to make an inference on something. So by defining it to be just fall of 2020 and just this one stats class, the results we generate are going to be used to make an inference on why students missed Professor J's class during that semester. It's not going to be applicable to anything else. Now, a good way to introduce statistics is really just to jump into how it's used in our field. When you conduct research, it's all based on the idea of hypothesis testing. And in hypothesis testing, you have, once again, two essential components. You have your null hypothesis and your alternate hypothesis. These two components can take many shapes, but think of it like your null hypothesis as what you already know, and your alternate hypothesis as what you're testing to see if there's any significance. You might see your null hypothesis phrased like variable A does not affect variable B, and your alternate might be similar to variable A increases or decreases variable B. It's any kind of simple relationship like that, and that's the focus of all research, proving something called significance. A result is significant when it demonstrates that it caused a change in another variable, that its independent variable, which could be anything, it could be a college classification, it could be somebody's gender, so many things that it could be, causes a change in another variable called your dependent variable. This could be their grades, so maybe you're saying freshmen make better grades than sophomores on average, or seniors have lower rates of anxiety than freshmen, which there are some good studies about, which I'm going to be looking at next semester too. There's two outcomes that we state when determining significance. You either reject the null hypothesis or you fail to reject the null hypothesis. Now, listen carefully here. You do not say that you accept your null hypothesis or you accept your alternate hypothesis. You're simply rejecting your null hypothesis or you're failing to reject it. That's really important whenever you think about it. So you either reject it, and that means that there's no correlation that you found, in turn meaning that your variables don't affect each other, or you fail to reject it, meaning that you fail to demonstrate that the variables meaningfully affect each other. Now, the aim of statistical analysis is to prove the significance is not caused by random chance. Two results can be significant, but they might not have any correlation at all. An example of this I can think of off the top of my head is in my abnormal psych class, we were talking about pedophiles, and there are two physical differences with pedophiles that our professor brought up. He said, on average, if a pedophile is a man, they are shorter and way less than other men. And we gave our theories, and maybe malnourishment in childhood relating to abuse or neglect. And the other one that he brought up was that pedophiles tend to be non-right-hand dominant. So either ambidextrous or, left-handed only. And we were talking about this, and I said, that's strange. That seems like something that might be correlated, but not necessarily be a cause of pedophilia. And we kind of talked about it. And one of our classmates went and looked up the study that showed this, and they were correlated. So there was statistical significance, or they were significant, sorry, not correlated. But there had absolutely no correlation. It was super, super low. Now, whenever we've proven, a little side rant there, sorry. We've proven that our significance is not caused by random chance. So now what we're going to do, or we're trying to prove that it's not caused by random chance. So what we do is we choose from any of our array of statistical tests. They take a lot of defining. They're all useful in different scenarios. It could be talked about on a video of its own, just when you'd use all of them. So your goal when you conduct these tests is to figure out if your results fall past a certain number, called your critical value, that demonstrates that random chance is not causing the result in your study. You do this by adjusting something called your alpha level, which is represented by the Greek symbol alpha. Typically, alpha levels are set to alpha 0.01, 0.05, or 0.1, and usually in the studies that I've read, it's 0.01 or 0.05, usually the first of the two. Now, there's an issue with changing your alpha level, because that is the issue of error, and there's two types of error whenever you can do a statistical test. There's type 1 error and type 2 error. Type 1 error is better known as your false positives. It's where you reject your null hypothesis when you should have failed to reject it. Alpha is simply the probability that you make that error, where you reject it when you should have failed to reject it. So by lowering your alpha, you ensure there's less of a chance that you reject it when you shouldn't have rejected it. And then type 2 is the inverse. It's known as a false negative, where you do not reject the null hypothesis when you should have rejected it. And beta, the Greek letter beta, is the chance that you make a type 2 error, and it's the inverse of alpha. So if your alpha is 0.1, then your beta is 0.9. I think a great way of demonstrating the importance of statistics is by actually making a hypothetical, just kind of loose research study. So let's say you were to design a research study that's focused on someone's daily mood after reading their horoscope. I take and establish two groups created on a belief criterion. You have people who read their horoscope and believed it, and those who read it and did not believe it. So my null hypothesis is going to be people's daily mood is not affected by the perceptions of the accuracy of their horoscope. And then my alternate hypothesis would say people's daily moods are affected by their perceptions of the accuracy of their horoscope. Then I might go on to elaborate that those who believe their horoscope is more accurate might have a lessened daily mood, but that's besides the point. So I'd set my alpha to a certain level, let's say 0.01, because it's the lowest chance for a type 1 error. I'd conduct my research, get my results, and analyze them. And it's important to note that if your test reveals that your significance is 0.02, even though it's super close to your alpha level and your critical value, you cannot change your alpha level after you put your research proposal through to something like 0.05 to adapt and fit your test results. You must declare that you are unable to find significance at your alpha level. This is to ensure that all results are valid and consistent. It's a common ethical practice among researchers to ensure that their tests stay, I think valid is the word I'm looking for. Water! I love water. It's also important, you say that your results come back significant, so they fall past your critical value. I'd state my findings as follows. It's something like there was significance proven at alpha equals 0.01, where your power is, whatever. That's your correlation, which is another topic. Thus, the null hypothesis was rejected. And it's important to, we're doubling back to earlier a little bit, but the reason we state that the null hypothesis is rejected, rather than saying that your alternate is not accepted or is accepted, is when you conduct a piece of research, you're making a scientific observation to see if a result is invalid or not. You don't know the outcome of every time you repeat your test. So instead, what you're doing is you're rejecting the prior observations of your test or your prior conclusions and not accepting your current ones as truth, but just rejecting your old ones. So you don't know if your findings are the truth. You simply know that your null hypothesis was not the truth, so you reject it. Now, stats is a difficult area for a lot of people in psychology, but it's really the concrete base of everything you do. It's important if you hope to get into the research elements. Even if you aim to be a clinician and help work with people in therapy, you need to have a firm grasp of statistics if you want to comprehend the research studies that are going to be helping you and your clients, or if you want to be looking at the effectiveness of treatment interventions. I'm going to be doing my master's program with a concentration in psychometrics, which is going to help my understanding of statistics increase a lot. So I'm really hoping that will set me up with a firm foundation before I start doing some serious research. But I'm going to end the video there for now. There was kind of a lot, kind of a little at the same time. Other topics for you that you might be interested in for more stats related videos could be things like the central limit theorem, z-tests, t-tests. There's just so much stuff that you can cover. You can cover using the specific statistical programs, or maybe looking at research papers and dissecting their results section to really be able to understand it. They could use a whole video series on their own, and I might try to get to them later. But I really do believe that establishing functional definitions of things like of statistics and like populations really helps making learning them a lot easier. But that's all from now for me. Until the next time, I'm Brennan. Thanks for watching my video.